In this video, we're going to take a look at the molar mass and how it relates to the mole. So what is molar mass? The molar mass, in the simplest way you can look at it, is the mass of one mole of a substance. And the symbol for molar mass is uppercase M. So uppercase M is a symbol for molar mass. Some resources will put big M for molar mass, but either way, both of them work. The unit for molar mass is in grams per mole because it's the mass of 1 mole and specifically the mass in grams. So the mass in grams for 1 mole. You can get the molar mass from your periodic table. The mass on the periodic table is basically your molar mass. So usually it's your mass for one atom in atomic mass units. But when you're dealing with 1 mole, it's the same number, but the units instead are in grams per mole. So let's say we were to go to your periodic table. So let's go to our unit 3 calendar here and open up our periodic table of elements over here. And so if we go to sodium, we can see the mass of sodium is 22.99. And so what that means is that's our molar mass. Our molar mass is actually going to be 22.99, but instead of AMU, we're putting grams per mole. So the molar mass of sodium is 22.99 grams per mole. So in 1 mole of sodium, if you were to actually get 1 mole of sodium, you would put on a balance and you would see it's 22.99 grams. Or if I said, measure me out a mole of sodium, or mass me out a mole of sodium, you would say, okay, I need 22.99 grams of it, and I know there's a mole in there. So figuring out the mole of elements is pretty easy. You just go to your periodic table and find that mole. Find that number, I should say, the molar mass value. So figuring out the molar mass of elements is very easy. You just go to the periodic table, find your mass value, and you're done. And make sure you put grams per mole. But you'll also have to do this for compounds. When it comes to compounds, what you want to do is you want to add up all the molar masses of all the elements there in all their quantities. So we'll do an example. Let's start with the example of MgCl2. So I want to find the molar mass of MgCl2. So I'm going to put big M of MgCl2, like this. I usually make it a subscript, is equal to the molar mass of Mg plus 2 times the molar mass of Cl. Why is that? That's because there's 2 Cls. There's only 1 Mg. So you do have to look at the subscripts. You don't look at the coefficients, if there's any. You just look at the subscripts because you care about the compound itself. So that's going to be equal to, let's go look at our periodic table. We have magnesium is 24.31 and chlorine is 35.45. So 24.31 grams per mole plus 2 times 35.45 grams per mole. Now we're adding here and they all have 2 decimal places, so our final answer should have 2 decimal places as well because it's the smallest number of decimal places. So 24.31 plus 2 times 35.45. Make sure you know how to work your calculator to get the right answer there. And we get that it's 95.21 grams per mole. So a mole of MgCl2 would have a weight, or a mass I should say, of 95.21 grams in 1 mole of it. So let's try the next one. So we know that the molar mass of AlNO3 is going to be equal to the molar mass of Al plus, there's 3 nitrogens, 3 times the molar mass of nitrogen, plus there's 9 oxygens, 9 times the molar mass of oxygen. And so let's continue that over here. It's going to be equal to the molar mass of aluminum is, if we look for aluminum, 26.98. So 26.98. I'm going to leave out grams per mole for now to just save some space, but at the end we'll put it back. Plus 3 times the molar mass of nitrogen. So I believe that's 14.01. Let's just go double check. 14.01, that's right. And oxygen, we can see 16.00. So we got that already as well. So 14.01 plus 9 for the molar mass of oxygen there times 16.00. And they're all going to have essentially 2 decimal places. So we're going to end up with 2 decimal places at the end there. So 26.98 plus 3 times 14.01 plus 9 times 16. And we get that the molar mass is 213.01 grams per mole. 213.01 grams per mole for the molar mass of aluminum nitrate. So you do have to make sure you use the same periodic table that we do, because some periodic tables have different estimates or different rounding. So if they have different rounding, you're going to be a little bit off if they report it to a different number of decimal places. So do make sure you're using our same periodic table. So let's try the next one here. The molar mass of NH4, 3, and then PO4. So I'm just going to carry that one over here. So molar mass of that, molar mass of NH4, 3, PO4 is equal to, let's see, 3 times the molar mass of nitrogen plus 12 times the molar mass of hydrogen plus molar mass of phosphorus, or just 1, plus 4 times the molar mass of oxygen. And so that's going to be equal to, I'm going to leave grams per mole out for now, and I'll put it at the end. So 3 times 14.01 for the nitrogen, plus 12 times, is it 1.01 in our periodic table? Let's go take a look. If we're not sure, we always go back, take a look. Periodic table is 1.01 over here for hydrogen. So plus 12 times 1.01 plus phosphorus. Let's go take a look at phosphorus right here, 30.97. Plus 4 times 16.00. Let's go ahead and write that in, or type that into our calculator. So 3 times 14.01, and put that in brackets, plus 12 times 1.01, plus 30.97, plus 4 times 16, and we get 149.12 grams per mole. And so that would be the molar mass of NH4,3PO4. NH4,3PO4. And again, you need to make sure you're using the proper periodic table. Otherwise, if there's different rounding that occurs, you won't get exactly at the number we're looking at, and every time you're off, it'll throw your answers off for other questions. So that was the video on how to find the molar mass using your periodic table. Again, the molar mass is just the mass of a substance if you had 1 mole of that substance that you were massing out or weighing on an electronic balance, or even on a regular old triple beam balance. In the next video, we'll see the relationship between moles mass and molar mass and particles with a bunch of formulas using the concept of molar mass and conversion factors.